To find the inverse of a square matrix A, size 3 by 3 or larger, we need to build another matrix which has A on the left and the same sized identity matrix on the right. For example, to find the inverse of A equals row 1, 5, 7, 4, row 2, 3, -1, 3, row 3, 6, 7, 5, we need to build a second matrix with A on the left and the 3 by 3 identity matrix on the right. Sometimes when we're finding the inverse of a matrix by hand, and we want to remind ourselves that A is on the left and I is on the right, we place a dotted vertical line between them, but it's not necessary. Now, we'll use elementary row operations on this 3 by 6 matrix to write it in reduced row echelon form by hand. But you already know how to use the RREF function of your calculator to do this, so let's check our work before we even get started. Go ahead, push pause, and use RREF to write this matrix in reduced row echelon form. Of course, you cannot enter the dotted line in your calculator. Did you get row 1, 1, 0, 0, 26, 7, -25, row 2, 0, 1, 0, -3, -1, 3, and row 3, 0, 0, 1, -27, -7, 26? Did you notice that the left-hand side is now the identity matrix I? Guess what the right-hand side is? Yep, it's A inverse. So A inverse is row 1, 26, 7, -25, row 2, -3, -1, 3, and row 3, -27, -7, 26. Before we learn how to do this by hand, you should push pause and verify that we have indeed found A inverse by multiplying A times A inverse and then A inverse times A to see if you get the identity matrix I. Okay, let's find A inverse by hand. To do this, we first build the same 3 by 6 matrix with A on the left and the identity matrix I on the right, and then we'll use the elementary row operations to write this matrix in reduced row echelon form. In other words, we'll use the elementary row operations to RREF this matrix by hand. What's that, you say? We haven't learned about the elementary row operations? Well, actually, you use the elementary row operations without realizing it when you use the method of elimination to solve the system of equations on page 3 of Lab 7. But let's officially state the elementary row operations here before we use them to write this matrix in reduced row echelon form. 1. Multiply any row by a non-zero constant. This means we can multiply any row by any number other than 0, and the resulting matrix will be equivalent to the original matrix. 2. Add one row to another row. This means we can take a row and add it to a second row, and we will still have an equivalent matrix. 3. Interchange any two rows. This means we can swap rows and still have an equivalent matrix. Okay, let's see how these elementary row operations work. Our goal is to make the left side of this matrix look like the identity matrix I. In other words, we need to get 1s along the main diagonal and 0s in the entries below, and then above the main diagonal. We'll work on getting 0s in the entries below the main diagonal first. Let's start by eliminating the first entry in row 2. I like to keep track of what I'm planning to do to a matrix by writing a little note to myself alongside of the matrix. Now, the first elementary row operation says that we can multiply any row by a constant, and the second elementary row operation says that we can add any two rows together. So I think I'll multiply row 1 by 3 and then multiply row 2 by -5. Then I'll add them together and put the results back in to row 2 so that we get a 0 in the first entry of row 2. We've written down our plan, so now let's execute it. First, we multiply each entry of row 1 by 3 to get 3 times 5, or 15, 3 times 7, or 21, 3 times 4, or 12, 3 times 1, or 3, 3 times 0, and 3 times 0 again. Next, we multiply -5 times each entry in row 2 to get -5 times 3, or -15, -5 times -1, or 5, -5 times 3, or -15 again, -5 times 0, -5 times 1, and -5 times 0 again. Now we need to add the corresponding entries of these two rows together to get 15 plus -15, which is 0, 21 plus 5, which is 26, 12 plus -15, which is -3, 3 plus 0, which is 3, 0 plus -5, which is -5, and 0 plus 0, which is 0. So our brand new row 2 is 0, 26, -3, 3, -5, 0. So now we need to rewrite our matrix with its brand new row 2. We keep rows 1 and 3 the same, even though we used row 1 to build the new row 2. This is our new but equivalent matrix. We're done with the first matrix. Let's make some room and move this new matrix up.